Imagine a supercomputer that can process billions of dollars in transactions, execute complex financial agreements automatically, and never makes a single mistake in math. Now imagine that same computer has no idea what the temperature is outside. It doesn't know who won the Super Bowl. It can't even tell you the price of gold. It is completely deaf and blind to the world around it. This is the reality of blockchain technology, and the consequences of this limitation have cost people billions of dollars in DeFi exploits. Right now, the Bitcoin network is processing transactions worth billions. Ethereum is running thousands of applications. But here's what will blow your mind. Bitcoin doesn't actually know the price of Bitcoin. Ethereum cannot check the weather. These networks exist in a perfect, isolated bubble. They are geniuses living in a sealed room with no windows, no doors, and no connection to the outside world. And this isn't a bug. It is actually by design. To understand why, you need to understand what blockchains were built to do. At their core, they are trust machines. They solve one specific problem. How do you get strangers to agree on what is true? The answer was brilliant. Create a system where everyone has the exact same copy of every transaction. Make it mathematically impossible to cheat. But to achieve this, blockchains had to make a sacrifice. They had to become completely deterministic. Deterministic means predictable. If you give the blockchain the same input, it must always produce the exact same output. Every single computer on the network needs to verify every transaction independently and arrive at the exact same conclusion. If even one computer gets a different result, the system breaks. This is why blockchains can't just browse the internet like you and me. Think about checking the weather. You make a request to a server and it sends you data, but that data changes constantly. If I check the temperature now, I might see 72 degrees. 5 seconds later, you might see 73. Now imagine 1,000 computers on a blockchain trying to verify a smart contract that says, if the temperature hits 75 degrees, send payment. Half the network checks at 10 a.m. and sees 74 degrees. The other half checks a minute later and sees 75. Now half the network thinks the contract should execute and half thinks it shouldn't. Consensus is broken. The entire blockchain breaks consensus. This is called the Oracle problem. It is one of the most fundamental challenges in crypto. Smart contracts are incredible. They can hold money and make decisions automatically, but they are trapped. They can't make an API call. They can't access a database. They can't load a web page. It's like being the smartest person in the world, but locked in a soundproof room with no Wi-Fi. So what happens when you need a contract to interact with the real world, like an insurance policy that pays out if a flight is delayed, or a betting platform for sports, or a trading app that needs stock prices? Someone has to tell the blockchain what happened. That someone is called an oracle. An oracle is a bridge. It fetches data from the real world, from APIs, websites, and markets, and delivers it to the blockchain in a format it understands. Sounds simple, right? But here is where it gets dangerous. Blockchains were built to eliminate trust. You shouldn't have to trust a middleman. But the moment you introduce a centralized oracle, you reintroduce the exact problem you were trying to solve. If one person controls the oracle, they control the truth. They become a single point of failure. If they lie, the blockchain will execute the contract exactly as programmed, but based on false information. It's like giving a genius mathematician the wrong numbers. They will calculate the wrong answer with absolute confidence. This has happened in real life multiple times. There have been cases where price oracles were manipulated and millions of dollars were drained from decentralized finance platforms. Attackers figured out how to feed false prices into the system, tricking smart contracts into thinking assets were worth way more or less than reality. The contract did its job. The math was perfect, but the output was catastrophic. The industry is working on solutions. Some projects use decentralized oracle networks, where multiple sources are averaged together. If one oracle lies, the others outvote it. Others use cryptographic proofs to verify data sources. But none of these solutions are perfect. Every connection to the real world introduces risk. And here is the paradox. Blockchains are the most secure computing systems ever created. But the moment they open a window to the outside world, they become vulnerable. They have to trust something, a data provider, an API, a human. It is like building an impenetrable fortress and then realizing you have to leave the front door unlocked so the mailman can deliver the news. Until we solve the Oracle problem perfectly, blockchains will always be limited. Geniuses in a box. Powerful, precise, but isolated. Every time we build a bridge between that box and reality, we are making a bet. A bet that the messenger is telling the truth. Because if the messenger lies, the machine makes a mistake. And on the blockchain, mistakes are permanent. However, there are networks like Chainlink. They realized that if the Oracle is the weak link, you need to reinforce it. So instead of using one messenger, they use a decentralized Oracle network. Let's talk about it next.